Example 4. Write a possible explicit rule for the nth term of the sequence. So here, we're given a list of numbers and we're wanting to figure out what our explicit rule is. First thing, whenever we're tasked with writing an explicit rule, is try and figure out, is there a constant difference happening between our numbers? So if I'm going from 5 to 10, that's adding 5. Jumping from 10 to 20, that's jumping 10. 20 to 40 is jumping 20. 40 to 80 is jumping 40. That's not consistent. That's not a constant rate of change, which means we're not dealing with a linear relationship here between these numbers. We're not dealing with a pattern that fits a linear model. If we go through this process again, we look at 5 to 10, well, that's a jump of 5. 10 to 20 is a jump of 10, and 20 to 40 is a jump of 20. That's, again, not consistent, which is telling us that it's not a quadratic model either. It's not like I'm going to be taking n and squaring it and then doing some math with my numbers from there. So it's not quadratic because we don't have a constant second difference or a second rate. The other thing we have talked about this year, it's been a little bit, are ratios. When you have a constant ratio, it's representing something that is modeling exponential. The way you find constant ratios is you divide your numbers from the end of your list forward. So I'm going to take 80 divided by 40, and I find that that gives me 2. 40 divided by 20 is 2. 20 divided by 10 is 2, and 10 divided by 5 is 2. What this means is we have something that's modeling more exponential. And what that means for us when we're trying to go and write our explicit rule is I have a base of 2 with an exponent of n minus 1. So when you find that you have this constant ratio, and you might be thinking, wow, this is such new information, and that's okay, this is new. We've not really talked about this before. So it's okay if you're feeling like this is pretty abstract and pretty unfamiliar, because this is the beginning conversation of looking at problems like this, so it's okay. So when you find that something has a constant ratio, whatever that constant ratio is, in this case 2, that is going to be the base of your exponent n minus 1. From there, you then look at, well, what is my first term in this sequence? And my first term is 5. And so 5 is then going to be multiplied out front to get our explicit rule. So a general way you can set this up when you find that you have a constant ratio with your list of numbers is you're going to take your first number in your list times whatever that ratio is to the power of n minus 1. Or if you want a more mathy way to write it, a sub 1 times r to a power of n minus 1. So we talked about a linear one in that last slide. When you have something that's linear, when I was introducing these explicit formulas, and when you have something that's linear, you go through and you figure out your slope and you multiply that by n, and then from there you kind of do a little bit of math and trial and error to figure out if anything needs added or subtracted. Well, when you have things that model more exponential like this is what you're going to use down here. This is what you'll want to be using to help you out, where you take that ratio, whatever that is when you divided those numbers and you got that constant ratio, that is going to be to the power of n minus 1, and you're going to multiply that by whatever the first number is in your sequence. And in our case, it was 5, and our ratio was 2.